What
Yeah,
is it?
it's a Piper. It's like a Piper Cub.
Yeah.
Yeah.
I think it's a fix racer in there.
Yeah.
It's missing.
Really? I think PixRacer can power this thing.
Yeah, no problem. In fact, we've got another one, and we are putting a Pixhawk into it with some very powerful servos. So it'll have an autopilot. Yeah.
Ah.
So yeah, we do
So
play a lot.
should I start the show?
Okay, guys, if you're ready, we can start this show, and show must go on. So, and let me introduce with you Oleg Kalachov. He's an amazing guy, and he is a lead developer of COEX, of the world and of the universe. Okay, Oleg, let's welcome and talk us some interesting features about the Clover platform.
Thank you. Good day. Thank you for coming, everyone. This is actually, I think, the first webinar or lecture about this subject in English of mine. So this is. I hope this would be interesting for you. We have here not so many people, so I would like to have it as much interactive as possible, so you can answer any questions in any moment. You can use your voice. There can be situations that I, for some reason, will not understand you, and then if you write in the chat, then I will definitely understand it. So you can ask any question about the platform. I'm not sure that every one of the viewers is the participant of Copter Hack. Is it like this or not? Because here the things I'm gonna tell you about are more related to the Copter Hack and your participation on it. Because I'm gonna tell you about the Clover platform, and I hope you will use it in our hackathon. Actually, I have a kind of a plan. So this slide shows the plan of my webinar, and I'm gonna go by it. And the first thing that I'm gonna tell about is what is the Clover platform. I think most of you are familiar with this and know kind of what is it, but I'm gonna tell you very in detail what is it and what components it consists of. The Clover platform is a platform for programming autonomous drones and for assembling an autonomous drone, for flying manually, and for programming the autonomous flights. And the main components of this platform are PX4 flight controller and ROS framework with our packages. And physically, PX4 runs on a Pixhawk or PixRacer compatible board. In our case, this board is called COEX Pix, and this is totally PixRacer compatible. And this board runs PX4. Actually, in Clover platform, we have a fork of PX4, and we have made some changes that simplify the configuration and its usage basically for autonomous programming. Actually, our platform is somewhat compatible with a regular PX4, so you can use it if you want, but our fork is easier to configure, and also it has some issues fixed that are not so critical, but still they are issues. So this is the first part, the PX4 flight controller. Actually, PX4 is not only a flight controller with open source code that can be used for autonomous flights. Also, popular flight controllers include such as ArduPilot. Maybe you've heard of it. Betaflight is much less popular for autonomous programming, but also used, and some other software that also sometimes used for autonomous flight. But for my sense, the PX4 is the most popular flight controller for autonomous flights. It's born in academy environment in Switzerland, in Zurich, and a lot of very smart scientists contribute to it. So that's why we have chosen this flight controller. Also, we like that it's very extendable, and you can modify it and update it more or less in easy way. Also, it supports wide range of targets of boards that it can be run on, but PixHawk is the most used. So we use PixHawk or PixRacer compatible board. All the information you might want to know about PX4 you can read on its official site. So the site is px4.io. It has a lot of articles. It has the official documentation, and there's a lot of useful information. But our platform, Clover, also has its own documentation, and it's located on the site clover.coex.tech/n. And here is also a lot of information on PX4, but the mostly related to our kit or our autonomous flights platform. So this is PX4 component of our platform. The next component is ROS platform, and ROS platform ROS is a framework for creating robots, for creating robotic software, and we have chosen it for as a base for our packages because it's also really popular in academic environment, and if you read all the state-of-the-art articles on robotics in different journals, you can see that a lot of people use ROS. It simplifies debugging, introspecting, and monitoring, and it has a lot of useful ready packages that you can use. So that's why we have chosen ROS for our platform as well. So for as a board for running the ROS part of our software, Raspberry Pi is used. So our drone has two main computers. The first one is PixRacer or COEX Pix running PX4, and the second one is Raspberry Pi running the ROS platform and our software. Actually, it's not so easy to install ROS on the Raspberry Pi. if you are doing it from scratch, you should execute a lot of commands and wait a lot of while it's building. So we have decided to simplify this task. We created a builder and for an image file for an RPI. So when we want to release a new version of our ROS platform, we just make a tag in a Git repository, and automatic build system in our CI builds the image for us, and we can download it. We just download this file. We use a special software called Etcher for flashing this image to SD card. And then when we insert this SD card to Raspberry Pi, it's just ready to use. So you can start programming autonomous flights really quickly. And the most of the time I want to talk about our ROS platform and the new releases of these images, because we have 2 new releases, and I'm going to tell you the changes that we have made in detail. So if you want to download our image, normally you just go to our documentation, as I said, Clover .coex.tech, and here in section working with Raspberry Pi, we have an article RPI image, and this article has a direct link to the image file. But if you want to see full list of versions and changes, there's a more interesting way of doing it. Then you need to go to the repository of our platform. So this is our official repository, and if you want to see all the releases that we have, you can go to releases section, and here you see the full list of releases available. And the releases I want to talk today is basically this release 0.21, and this release that you might not see, but I will make that you will see now, actually. I just click publish release. So now you'll see it as well. But first of all, I'm going to introduce the set of software that we provide on this image and how to use it basically. I will not show you real flights because I'm not in a place where I can do it, but I show you the simulator. I hope most of you are familiar with the simulator, but for those who are not, I will show you that we have other repository which is called Clover VM. This is a ready to use virtual machine image file with Linux, and it has all the ROS platform that I talked earlier and all the software installed, and also it has PX4 simulator installed. And if you import this image file in my case, VMware software, VMware Fusion, then you see the Linux operating system with several useful links. And if you want to run the simulator, this is very easy. You just click Gazebo PX4, and the simulator will run. As I said before, this link runs PX4 Gazebo simulator, and it runs all our platform software automatically. So if you open the terminal, you will have almost the same set of tools as you have on a real Raspberry Pi on a Clover drone. For example, you have here all the ROS instruments. I hope you see the font. It's not small or blurry. Yes?
Yes.
Yeah. So you have all the ROS tools available on a real drone. And if you're familiar with the API of autonomous flight, you can just use it, and the simulated drone will execute your commands. For example, here's a command that takes off the drone. It works on a real Clover drone, and now I'll show you how it works on a simulated drone. We use Navigate ROS service. We ask the drone to fly, to take off 1 meter, and let's execute it. And the drone should take off. Also, you can notice that everything is pretty slow. You see here real-time factor value, and when it's 0.2 or 3, it means that everything is slower than it would be in a real life with 0.2 coefficient. The reason for it.
Oleg, just a moment. Could you increase the font in next time? Okay, it will be better for the video on YouTube.
Font in terminal, you mean?
Yeah.
Okay, and I have increased it.
Thank you.
So if you don't have Clover drone, you can use just simulator, and the changes that exist in the most recent releases, almost all of these changes, not all of them, but almost all of these changes are already in the in this image. I haven't.
Can I ask a question?
Yes, of course.
What are the topics that are used to determine the height of the quadrotor here? Like in simulation, we can use like ground truth, no, but on the quadrotor, the real one, how do you determine the height of the quadrotor?
You mean how to get the height that quadcopter estimates?
Yes, exactly, the feedback.
Yeah. This is actually part of the Clover API. It's also a ROS service that it's called Get Telemetry, and it's when you call it, you will get the full estimation of what the drone thinks about its state. You will get.
Yep, I understand this, but like you are using just IMU with the pressure sensor. What are the sensors like? How much is it like precise? For how many centimeters or something like this?
In this configuration, in the simulator and on the real drone, it's have a laser rangefinder installed. STM laser rangefinder, and the drone uses this rangefinder as one of sources of the height data. Yeah.
Okay, I understand. Thanks.
Another system that we use very often is markers that are put on the floor. Maybe you have seen it. We really oftenly put visual markers on the floor, and the camera on the drone recognizes these markers. And actually, the drone takes the 3 coordinates mostly from the markers. Of course, it uses IMU as well, but the main source for position is markers. But our software platform includes optical flow algorithm for the camera, and when there is no markers like now, it uses optical flow for determining X and Y, and also it uses laser rangefinder for determining the altitude, the height of the flight. And when you want to get the feedback, you can use this service, get telemetry. You should provide the coordinate frame for it. And then you get all the information, X, Y, Z, velocities by all the 3 coordinates, orientation of the drone, voltage on the battery, and so on. Actually, I forgot to say, but so this is a repository with this virtual machine image, and when you want to download the image, of course, you go to releases section as well as it was on the main Clover repository, and here you can find download link. And also, this simulator has a documentation on our main documentation site, and to find it, you go to programming section, and then you go to simulation section. And this section has 3 articles about installation of our software set yourself, which is not really easy, and you can meet some errors while doing it. The easiest way is just use a virtual machine image. It's described in this article. And then you will get the article about some tips on usage the simulator. Also about the API that we have for controlling the drone. When you want to get all the information about this API, you just can go to the main programming section, and it has some examples, and then it has a link to autonomous flight article, and this article has information about all the ROS services that are available to the user by our API. I mean, all the ROS services are related to the commands for autonomous flights, but not all the ROS services or ROS resources available, only related to the autonomous flight. As you have understood already, ROS has a way for inter-process communicating when one process, which can be your user program, asks another process, which is our API, to do some stuff. You've seen that I asked navigate, which means to fly to another point, or you have seen how I called the telemetry service to getting the feedback of what is happening. Actually, this way of communicating is called services, ROS services. This is the implementation of a pattern called remote procedures call. So when one node or module of the ROS system defines a service, and other nodes or programs can call these services and get the result. And if you want to see all the services that are available, you can use command service list. And when you call it, you see the list of the services available. Most of these services are described on this page, but some of them are just kind of a standard ROS services. ROS services is not the only way for communicating with the platform. Another way is topics. Topics are named message queues that one programs can send to other. And the Clover has a lot of topics as well. And when I want to list the topics available, I just use the command topic list. And when I input it, I see the full list of topics. As an example, I can show you the topic called rangefinder/range. This topic is published by rangefinder driver on a real Clover and rangefinder simulator in the simulator. And this topic contains the data from the rangefinder. So for viewing the data from the topic, there's a lot of ways to do it, but the basic way is to type topic echo and the name of the topic, rangefinder range. And when I type it and I hit enter, and I'll see the data in this topic. And you see that I have asked the drone to fly 1 meter, 1 meter altitude, and the rangefinder now shows me that the altitude is near 1 meter. Of course, ROS has tools for visualization of this data. You can plot it using RQT multiplot tool, and you can, for example, I can replace echo to HZ, which means hertz. And with this command, I can view the rate of the data in this topic. And you see that the rate in this topic is 10. And the real-time factor. So this is not working real time. This is working slower than real time. But here, this is considered. So my rangefinder is simulated in a rate of 10. And although my computer works slow, I see the real rate of the simulated sensor. So this is the basic information about autonomous flights API. All of these services work. Get telemetry for getting the state, navigate for navigating to the point, and so on. And you can use it for your projects, for Copter Hack, or for anything you want. And the last service I'm going to show you as a brief talk about this API is land. It's very simple. I will write ROS service call land, and of course, what it does, it's just lands my drone. So my drone lands. So this was a brief review of the autonomous flights API. I can answer questions on these subjects because now I'm gonna talk about recent changes. So, are there any questions? I think this thumbs up means that you have question. Yes. You can speak, or you can write to the chat.
Oops,
Thank
sorry.
you, Mustafa. Very
I
important.
just wanted to say that we're good. I don't have questions. Sorry.
Okay. And I see some very interesting message. For me, it's means nothing, but I can say that the letters of Arabic alphabet is really looks interesting for me, but they don't mean anything. Now I'm gonna okay, another message. Okay. And by our plan, I briefly covered these subjects, and now platforms recent releases. So we have actually 2 recent releases. And the first of them is version 0.21. It's already a final release, so you can download it. We tested everything, and everything works. And it has the biggest change it has is it introduces blocks-based programming. And why I want to talk about this in detail now, because I believe that block-based programming is a good example of project that can be done for Copter Hack. So we will definitely appreciate such projects, and I will show you how it's done. Actually, are there a lot of people who participate in Copter Hack or not? For example, Mustafa, are you a participant?
Yes.
Yes, that's great. And what is your project about?
That's a very good question. I didn't study it.
I didn't get it. Okay. So block-based programming. I will show you at first how it works in the simulator. So now my simulator is running, and if I open the browser Firefox, for example, and go to okay, where is my Firefox? It opens. Everything is really slow, and Firefox is okay. It's opening really slow. I think I'm going to restart the simulator. Maybe it will help. Why it's not closing? Okay, let's start it again. Let's run the simulator. So you on the simulator, you just go to Everything is really slow for some reason. You just go to the localhost address, and when you use it on a real drone, you go to the address of a real drone IP address, and you will see this page. And I forgot to say that in Clover platform, everything is configured on the launch files. In launch files, launch files are automatization files for ROS systems, and such launch files have all the configuration for the system. ROS cd command opens the package, Clover package. Now I want to open the Clover package folder. I go to the launch directory, and the main launch file for the Clover platform, either on the simulator and here and on a real drone, called clover.launch. And if I want to enable block-based programming, I should change this value, which is false, to true. Argument named blocks are equal to true. Now I save it. And now I launch the simulator again. On a real Clover, to apply the configuration, you should use the command sudo systemctl restart Clover. Here's the command for restarting the system on a real drone, but on the simulated drone, you just have to restart the simulator. And now I can open the main page of the platform, and it has link to blocks programming. I click to this link, and I have the interface of blocks programming of my block-based program. Okay, I can assemble a really easy program. I want to make the drone take off to 1 meter. I want to fly 1 meter forward, for example, and then I want the drone to land. Also, I can switch the state of LED strip between landing and navigating, and I can do it as well. So here's my really easy program. And then I just hit the run button, and it should. So note that the program starts instantly. So when I hit the start, the program starts instantly. Another interesting thing to note, that my blocks-based programming interface highlights the current executing block. So now the drone executes takeoff block, and it's highlighted. So the next block is executed. The drone navigates 1 meter forward, and now it should change the LED. Yes, it changed the color of the LED, and then it lands. So this works the same way on a real drone. And I want to tell you the techniques we used to make this plugin, or to make this extension for Clover. First of all, what we of course this blocks platform is not created by us. We use Google Blockly. Google Blockly is a platform for creating block-based programming for everything you want. You can create blocks-based programming for a drone, for any robot for I don't know. You create blocks you want, and then you just tell Blockly how to convert the program that user assembled to a code on a real programming language, and in our case is Python. So in this interface, there's two tabs. The first is blocks, and the second is Python. And when I click Python, I see the Python code that is generated by this block-based program. This toolbox has a lot of blocks that are pre-built in a Blockly, but flight section, state section, LED, and GPIO sections has blocks that created by us. So for each of these blocks, I have told the Blockly how to make Python code for it. For example, if I just leave only takeoff command, I see that this command calls navigate wait function, and this function just calls navigate service that I told before, and then it just waits until the drone reaches the target point. And this way we can allow the user to assemble very complex programs. The user can use every math operations and everything else. It can use if blocks. They can use repeat blocks and so on. And all of this stuff is converted to the Python code, and we just send this Python code to the drone, and the drone executes it. And another interesting thing is how it's sent to the server. And the answer is that we use the same ROS services for sending the same ROS mechanics for sending the code and getting the feedback from the server. For example, if I type ROS service list, I see the service called Clover blocks/run. And this service just as a request, it has the code in Python. And when I execute this service with the code, it just execs this code, and the drone does what it should do with this code. I can show you the source code for how it's done. This is the ROS node that acts as the backend for this thing. And you see that here run service is declared. And when this service is called, we can go to the run function, and you see that it just use Python exec operator for evaluate the code. You get it, yes? So Python is a language that has an instruction to evaluate every program as a text string, and it just execs this code, and that's how it works. For example, if I use ROS service call Clover blocks run, I see, I can, for example, I don't know, which code I want to execute. How to show it the best way. Okay, so here actually the code is will be here, and if I run the program that prints 1, you actually see 1 here in the interface. It's also kind of a magic. So if I use this service to execute the program that prints a string, this string appears here. Yes. And the main question is how we call ROS services from the browser, because ROS services can be called from the terminal, they can be called from a Python script, but this is browser, it's a sandbox, right? And the answer is that we use a library that is called roslib.js. We can easily Google it, roslib.js. So this library allows you to use JavaScript in the browser to access ROS resources, ROS services, and ROS topics from the JavaScript code. So this is the source code of the blocks programming interface. It uses roslib.js to create a proxy for service that I showed you before, which is called run. And when I want to execute the program, I just use this proxy in my JavaScript code, and then I just call the method call service. I pass all the arguments I want. Now, in this case, is the code from here. I pass the code to the service, and I get the response. And this is really convenient for writing graphic user interfaces based on browser for your drone. So when you want to control or monitor the state of your application that you are writing on the ROS framework, you can use this library to communicate from the graphic interface in the browser with the ROS stuff. And this is this is used in this project, blocks programming support for Clover. roslib.js actually supports all the stuff that you might need. And I really like this library because in our platform, almost everything is available as a ROS resource, as a ROS service, or as a ROS topic. Another example of roslib.js usage in this project is how what is printed in the user program, how it appears here. That's interesting, and I will show you how it's done. When the program from here executed, I use a special variable to stores all the global variables available to the program executed. And here you see that I just kind of cheat the user program. I substituted a real print function, which just prints the text. I have substituted to our fake print function, and this fake print function not just prints the text, it publish the text to the topic, which is called print, Clover blocks/print. So all the stuff that are printed in the user program actually appears in the topic. So if I echo this topic, Clover blocks/print, I can use tab shortcut for autocomplete. And here you can see that when I want to print stuff from the program, for example, let's print the number, I don't know, this. Actually, this number appears here. And the graphic user interface of blocks programming subscribes to this print topic. You see that it subscribes to it. And when it gets a new message from this topic, here, it just append this message to here. So when something is published to this topic, it appears here. The similar mechanism is used for the input from the user. For example, this program that is called Takeoff and Land. No, not this program. Simple Flight. Yeah, this program uses prompt block for getting the information from the user. In a program, in the Python program, this block is generates, of course, raw input or input functions. So this function in Python 2 raw input is called, and in Python 3 input is called. But in the backend, we also cheat the program and we substitute raw input function to our input function. This function publishes the message of the input to the special prompt topic, which is called Clover blocks/prompt, and then it waits the response in the topic that is called input/ID of this prompt. And when it uses wait for message function for it, and when the user inputs their response, actually this response from the interface, it's published in this topic, and the executed program on the backend get this response and use it. I will show you how it works. So here this program asks the user which altitude they want to take off the drone, and then make the drone takes off to this altitude. So let's run it. So where is our drone? What is happening? Where is our drone? I've lost my drone. Here it is, I think. Yes. So let's run this program. I hit run. The message box appears, enter flight altitude. This is the graphic user interface received the message from the topic. I enter the altitude 3, for example. This my response has been published to the respawn topics, and the drone will take off to the 3 meters. This won't be so quick, but yes, it's kind of 1 meter, 2 meter, and this is 3 meter. Also, if I want to stop, I don't think this is 3 meter, but okay. If I want to stop the program and land the drone, also there is a button, land. I can click it, and the program is stopped, and the drone lands. And for this, we also actually use the land service. And when I click land service is called, and the drone lands. Okay, and the last thing I want to talk about this project is how we implemented that the current block is highlighted. This is done this way. Actually, Blockly allows me to insert any code I want between 2 blocks. And when I generate the program, I ask Blockly to one second. Here it is. I say that before each block, please insert this code. B function, and %1 means the ID of the current block executed. So actually, when we generate the program, we get something like this. So here's the program that is shown on Python tab, and here is actual program that are sent to the server. You see that it's almost the same, but between each calls of each blocks, so navigate is one block, and another block, another, and another, and between all of them there's B function called with the ID of the current block. And in the backend, we say that B function is actually a function that is called change block. This change block function changed the variable that is called block to the ID of the current block. And we have a timer, which is actually a code that is run every 0.2 seconds, so 5 times per second. So this timer actually publish the current block to block topic. So if I echo the block topic, this topic echo Clover blocks, and the topic is named block. So let's echo it. So now the program is not running, so the current block is empty. And when I run the program, So yes, here's my program. I click run, and you see the current block is published. I enter the altitude, and the drone takes off. And when it finishes taking off, where it is. Okay. So the drone takes off to 2 meters, and now when it finished, yeah, you see that the current block has changed, and the graphic user interface highlight another block. It's because we subscribe, of course, to this topic here. Here we subscribe to it, and when we get a new message in this topic, we just call block list function that is called highlight block with the ID of the current block. So here, how is this highlighting of the current block is implemented? And I should repeat that I believe that this is a good example of an extension for the Clover platform because it used all the ROS tools. It uses ROS-libjs library, and it's done in ROS way. So if you want to make something similar in your Copter Hack project, or if your project requires graphic user interface, then you may also use these tools that I have shown you. So this is all I wanted to talk about blocks programming support. And maybe some of you have questions. Okay, Mustafa said that this is very nice. Thank you.
Oleg, I have a question. And how can I commit something? You sent me a change of block, about PVM. And
how can you change a block, you mean?
Yeah,
or how
yeah.
can you append?
Yeah.
Okay. Actually, about your question, I have added a block for duty cycle, and we are planning to make a new release because we have found a bug, a small issue in this one, and we are planning to release a new version 0.21.1, and this new version will include the block for setting the duty cycle for PWM. But if you want to add a new block, then I will show you how it's done. At first, all the blocks list are located in blocks.js file in Clover blocks directory, and this is the full list of the blocks. If you want to add a block, you just add a block here. Each block has description of fields that you should fill for this block. So for example, the new block that you asked me, set duty cycle, has pin field of number type. It has duty cycle also of number type. And you also should set the tooltip of this block and so on. So here is the description of the block in terms of how it looks, what it looks like. Then we have another file, index.html, and here is a toolbox for all the blocks. So all the blocks that are shown in this interface, this is categories, and they are described here. Category math, category flight, and so on. So you add a block here and it appears in the toolbox. And then you should tell Blockly how to convert the code of your block, how to convert your block to the code in Python. And this is located in the file called python.js. And here we have the list of the blocks, and I just say that the block set duty cycle should be converted to a string set duty cycle, and it should use arguments pin and duty cycle as arguments to this function. So basically you just have to return a string of the Python code, and this string will be inserted in here. So this works this way. Okay, thank you for the question.
Thank you so much.
Okay, I will briefly describe another changes and updates that we have in recent releases. We have added a ROS www static package. What does it mean? It also related to the browser graphic interface for your project or for your extension. So if you want to create a web part of your package, now it can be done in easy way. So how it's done? For example, I create a new package. At first, I will enter to Catkin WS, which is the home for all the packages in ROS. Not all, but all. Okay, almost all the packages, because some of the packages actually located in opt directory, but never mind. So I want to create a new package. For this, I use command catkin create package. For example, I can name it foo. So my package is created. Now, when my package is created, I can use command ROS cd and the name of the package, and I will get to it. Like it's done with all the other packages, for example, Clover or I don't know, or Aruka Pose. And now I can get to my new package with the same ROS cd command. And if I want to declare kind of that my package has a web part, I just create a directory that is called www. And then I just create index HTML file, and I will write there, for example, hello world. And normally I would need to run kind of a server that serves this directory, but thanks for the new packages that we implemented, ROS www static, it's already serving. All I need to do is, on a real drone, I should restart the Clover services, but here I just have to start the simulator. I'm starting. No, first I should. Yes, I should start the simulator, but it's not started for some reason. Why it's not starting? It's starting, but I started a lot of copies of it. Okay, I just reboot the system because it would be the fastest way of fixing everything. So here's my package. I created a web part for it. Now I start the simulator. And now ROS www package executed. And now I just can enter the IP address in the browser. I enter the IP address of the drone, or in the simulator, it would be localhost / the name of my package, foo. And I see the web part of my package. So in the same, actually, Blockly user interface is served the same way. If I enter Clover blocks directory, I see that it has www directory and all the graphic interface I showed you before located here. I'm sorry. And this is an easy way to make a web part of your package. All you need to do is create a ROS package and create www directory on it. And here you can use ROS-libjs to communicate with ROS resources and make a nice user interface to control or monitor or debug your thing, your project. And this is all the important changes of the release 0.21, and there is a release 0.22, and all of the stuff that I showed you actually worked on Python 2, and I'm sure that everyone knows that Python version 2 is deprecated. It's not supported anyway any longer, and now the current version is Python 3. And for ROS platform, it's not so easy to transfer it to the new version of Python. We should move to the new ROS distribution, because current ROS distribution called ROS Melodic, and then the latest pre-release version is on ROS Noetic, and here we have ROS, and here we have Python 3. For example, I have my Clover drone working now in my network, and if I go to it using SSH, it will not work for some reason. My drone is not up, I believe, because I'm trying to use the same USB port for my microphone and for the drone, and there's not enough power, I think. So I wanted to demonstrate that the new version uses Python 3, and for the user, the only difference is, of course, that there is Python 3 syntax new, but for running the programs, the old programs actually should be run with Python flight Python command. So if I run this script, the drone will take off. But on the latest release of the image, this command will not work, because in the last release, we only have ROS support for Python 3. Not Python 2 don't have ROS support. So for the last image, the user has to write Python 3 flight py. But in the simulator, for now, it won't work because it has ROS melodic, not ROS naitic. But my drone is not up, so okay, never mind. And another change that we have switched to 64-bit Raspberry Pi OS. Before we used Raspbian, and Raspbian was 32-bit. So the Raspberry Pi itself, the Raspberry Pi platform, is 64-bit. It has 64-bit processor. But the Raspbian OS is Linux built for 32 bits processor. So the 64-bit nature of the Raspberry Pi was not used actually before this year. So on this year, new release Raspberry Pi OS is out, and we switched to it. So the new release actually should be a little bit faster because 64-bitness used. Okay, so here there was the main updates to the RPI image of Clover, and I hope you like our work and use it for your projects in Copter Hack, for example. So I covered almost all the subject, and the last subject I want to tell about is making ROS packages. So what is ROS package? ROS package is actually a directory in a ROS workspace. For example, our directory catkin.ws /src/foo. So foo is a package. And to make the package, and if you want to make a new ROS project, you can, of course, not make the package. You can just make a script and it will work. But if you want to use some additional features of ROS, for example, creating a messages for topics or services, or creating or building something, if you want to use C++, you will have to create a package. And to create a package, as I showed before, you just use command catkin create package. And let's create another package that is named bar. So we have created it. And what makes a package a package? It has package XML file, and package XML file has all the information about our package, and all depends of our packages. For example, if I open package XML of Clover, I will see that maintainer is me. I will see the link to the website, and I will see the ROS packages that are needed to this package. So we depend on a lot of ROS packages. And when you create your own ROS package, you fill this package XML, and later you can publish your package to ROS repository of packages, so everyone can install this package with one command like sudo apt get install your package name. And another important file of a package is cmakelist.txt. This file describes how to build things for your package. For example, how to build your binary or how to build message files. And actually, we can actually, this is to build everything that packages want to build, we use command catkin make. But I don't want to rebuild everything now. I use another target, which is called help. And this target will list all the targets I can build, all the targets that are exposed from ROS packages to be built. So let's run catkin make help. We see the list of the packages in this workspace. Now it's processing each package. The works not so quickly. For some reason. Okay. So here the full list of targets that can be built from our packages. These targets include building message files for topics and services, or binary files. For example, px4 is a binary of px4 itself. So this is the flight controller. I can rebuild it using command catkin make px4 if I want. And if I input command catkin make and press enter, that I will ask to rebuild everything. And what I can do, in my package, if I want to build something, I can use CMake list syntax. For example, I can add just a random target using directive that is called, let's Google, let's CMake custom target. Add custom target. So, for example, I want to expose a target for building from my package. I just write add custom target here. I'll name it bar custom target, and then I should input the commands to be executed. And for example, let's just echo hello to this target. So this is my target in my package. And now if I list all the targets, I will see this target, but I don't want to see the targets from all the packages. I can limit to only 1 second. It was a full target. It was a full packages actually. Okay, let's change it to full custom target. And then I can list all the targets available using flag pkg equals to full to list the targets only from this package. So let's do it. So it has standard targets, clean to clean all the artifacts, install, test, and so on. And here's my custom target, and I can execute it writing full custom target. And if I execute it, I see my message hello. And if I want to add a C++ binary to my package, of course, I can just create a C++ file and write my program. And when I want to tell the cat can make that this file should be compiled, I should use directive called add executable. So if I add this add executable to my CMake list, I will tell the CMake and cat can make that this file should be compiled. Okay, let's try to do this. I will leave this file empty to just get the error. Why not? And I will say that my package has executable named main or foo main, and it's located, and it has source code in src/main.c++. And then if I make help in this package, also I use a flag J to make it to parallel this task, to make it faster, to make 4 threads instead of 1. So if I make this help to this package, I should see my new target for compiling a binary file. Yes, so foo main it's called. So let's try to compile this binary, and it should give us an error. Yes, of course, because we don't have main function, but when you add the main function to your binary, you can compile it using this CMake platform. Also, if you want to make custom types for topics and for services, you create files for each your service type. For example, this is a type for navigate service file. And if I want to compile it, I use directive add service files with the list of my service file, and it will compile the service files to C++ headers and to Python files that I can use them from my programs. So I hope this also can be useful information for making projects in ROS, because if you want to distribute your project, the most easy and natural way of doing it is to create a ROS package for it, like we have done for all our things for Clover. So each of our function is a package. We have package for Aruka recognition, Aruka markers, which is called Aruka pose, Clover main package, Clover blocks that I showed you before, and so on. So maybe you have some questions about ROS packages. Oh, I have some messages in chat. Okay, thank you for thanking me. Okay, that was all the topics I wanted to cover in this talk. So Sveta turned her camera, so I think she wants to tell something, or
yeah, thank you, Oleg. So, Oleg, have you finished all topics which you want to say?
Yeah, I just maybe some final I don't know, wishes. I want to thank everyone who comes to our webinars. I want to wish them luck participating in our event, online event, in our competition. I hope they use our platform. I wait to we also always welcome your ideas to our platform, how to improve it, and we always welcome your pull requests to our Git repository. If you want to add something or if you want to fix something, you just send it to us, like a pull request or something, and we will accept it. So
also regarding to your last message, so could you show us, as I remember, at the Git book has an article about the Clover contribution. So if it's actually, you can show us.
Yeah, it has this article, contribution guidelines. The easiest way of contribution is to fix the documentation, and the documentation is written using Markdown syntax. If you see a mistake in an article, or if you want to add something, you just go to our repository and use any tools that GitHub provides to fix things. For example, I can say that I want to fix this camera article. I can click this edit button and edit anything I want, and then there will be create pull request button, and we will see your pull request and accept it. So this is the easiest way. And if you want to contribute to code, you clone this repository, or you use just a cloned repository in the virtual machine image, change everything you want, and this code is under Git source control. So you can use normal Git instrument, Git commit, and so on to commit your changes to your fork, and then send them as pull request, and then we will accept it. So this article describes all of these processes.
Oh, thank you. Thank you. Is it clear? Guys, maybe you have any questions, but I have prepared some interesting information for you. Okay, while you're preparing your question, I will.
Of course,
Yeah.
Huh?
Okay, you can.
Of course, you can ask all the questions. All the questions in our chat, Telegram chat, and we will answer them there also.
Yeah. Okay. So should I demonstrate my screen for it?
As you want.
Yes, of course I want.
So you want me to stop sharing?
It doesn't matter.
Okay, I stopped sharing.
I can interrupt myself. Okay, guys, I have prepared. You know that I like to do presentations, and I have prepared some presentation for this webinar too. So this is some summarize of this webinar. But Oleg told to you many things, many useful things, and I think it will help you in the further steps in your educational process, or maybe in Clover researchers. So you know that I heard about your questions about how many countries has joined us during this webinar. So, and I checked our registration form. So we have many different countries, but really amazing that so we start from Japan, we have Vietnam, Egypt, Barbados, Russia, Ghana, United Arab Emirates, Portugal, India, Mexico, South Africa, and Malaysia. So guys, it's really great that you have participated in this event, and really amazing thing that we have a big different time zones, starting from Japan. Japan has a +8 hours if we compare it with Moscow time, and also we have a participant attenders from Barbados. Barbados has a -8 hours if we compare it with Moscow time. So it's really amazing. So guys, it's perfect. So, and also you are, it's
Why do you
really,
have
sorry?
we had two bars for Russia, 2 bars there was. But okay, never mind.
Okay, so and now you are a part of a really great aerial robotics community, and our community has extended recently. So we have provided many online activities, and then the recent activities which about Oleg told before, named Copter Hug. During this activity, Canada, Mexico, and Japan was joined to us. It's really good. So, and also, you know that we are open to cooperation, and COEX, such as educational and industrial partner, can help you to build the educational and industrial process in your country. So write us and we will help you. So, and also Oleg told you about the Clover platform. And as you know, it's an open source platform. It is a really great solution to start from small educational drones and goes to the big industrial drones. It is very helpful to save money and drones if you want to teach students according to industrial drones. So start from educational and go to the industrial. Yeah, you know Clover platform and the famous slide in my presentation, of course. So if we talked about the programming, it's a really great focus for COEX Clover. Also, you can upgrade your skill in assemble and flight. And there are many interesting slides. So Oleg told you about events where you can participate with the Clover, with the knowledge of with knowledge which you have got during our webinars. Let's start. Of course, it's some competitions according to World Skills Russia, and we start our competitions open for students with age 12 years old. Also, you can participate in other international competitions such as IMF. Oleg knows more about this competition because he took a part on it in the last year, in the previous year. This competition very good for students from universities. Also, for students from university schools, we have another competition named Innopolis Open. This competition has a focus on indoor autonomous drones, and it's also international, and you can take a part in 2021 year. So about recently news, one of the most famous competitions, MBZIRC competition, so Mohammed bin Zayed International Robotics Challenge. This competition has two parts for indoor and outdoors navigation, and also they recently launched their registration form, and you can apply it to this competition before November 30. And also, this competition, it's really good, but they have only one task which you should to perform. We supposed you to take a part into other competition when you can realize your own idea. So it is mean Copter Hack. Copter Hack, it is a really great competition when you can create something new. So I mean about the different projects when you can perform accordingly with your project activity in your organization. It can be school, it can be university and more. So this is example of the projects of our students and interns. Face recognition systems, human pose estimation, charging station, and more. And also one of the most interesting projects which you have before, it is drone swarms, aerotaxi urban model. This project was developed in the previous year with school students, and also Oleg was moderator of this project too, and our teacher too. And on this video, you can see how about our other project. This is a 3D scanning drone. As you know, Timofey, it was the first project. It was him's first project. So he performed the system which allows to make a 3D scanning, such as a mobile platform. It was one of the first partnerships project between us, drone company, and company who makes 3D modeling. So, and finally, oh, sorry, it's some oldest slide. So application, we extend our application for international countries, for international participants up to end of November. So what about this competition? So this is a long-term competition. During this one, you can prepare in your own project, you realize your idea. You can start from now, and up to March, you will be work hardly, and also you will get more feedbacks from our experts and from other participants. And it's really interesting to see about other projects, about other ideas, and ask some questions and generate new solutions in this area. So, and also this solution will be open source, and you can base on it. The final part of the Copter Hack will be held in online in March 2021, in next year. Oh, also, we have a Kickstarter campaign at now where you can buy the Clover drone. So you can find the link here. And now we have a Clover. And also we have an item where you can buy only COEX peaks with such flight controller with GPS and PDB scheme. And also we have suggestions about the COEX Clover such bundle or COEX Clover school kit. So all information you can find here. So, and finally, join us, join our events, and thank you very much for your participation in this webinar. And also, if you have any questions, we are ready, glad to answer you.
I forgot to show something interesting. Really, I prepared a video, a short video. So this is an example of application in blocks-based programming. Very short video. So what is interesting? This is program that is written using blocks. You see that it's kind of complex, and here how it works on a real drone. So here you see it takes off. Flips and lands. So this is a flip which is programmed using blocks. It's really fun for me. Okay, that's all I wanted to show.
It's really amazing that you can create a flip by blocks.
Yeah. Stop share. Yes, stop share. Okay.
Okay. So guys, do you have any questions? And also, are you here now? No.
We have 15 participants.
We're still here. Don't worry.
Thank you, Damian.
Just at this stage, I'm going to have to watch the video again and study everything from the beginning to the end. So that is why I cannot ask questions at this stage. I don't know enough, but I'm getting there.
Damian, by the way, Damian, so we have spent the brick skills competition in the previous week, this week. So, and Damian, Damian was a mentor and teacher of gazebo simulation.
Of our configuration of gazebo.
Of course, yeah.
And of course, I only learned it the night before, so I was very qualified.
It was really amazing. So it was great experts' work.
Damian, can you program actually? Are you a programmer or not?
No, I definitely won't say I'm a programmer. Having said that, I mean, I've been involved in programming since day one, but you know, we're talking about in my days, it used to be things like Pascal and things like that. And then we started messing around with Arduinos and so forth. And then I did nothing for many years. And now that the students are involved in your package, I thought, okay, maybe I better teach myself something. So I can watch somebody code. I know exactly what they're doing. I can offer them advice, but I don't actually code, no. But I would like to get back into it.
But I know some interesting thing about Damian. So he knows very good about mathematics. And he tried to explain all flight trajectory using math.
Actually, gazebo simulation configuration is kind of in middle between mathematics and programming. It's more about configuration. It's more about dynamic model of the drone and so on. So if you are an expert in our simulation configuration, maybe you will fix it somehow or improve it, and we would like it.
Probably not, but like I was saying to Svetlana earlier, I was amazed at how easy it was to pick up on your gazebo world, and how quick it was to pick up on your Python code. I mean, I really spent one and a half evenings looking at it, and I could already get results, and that was fantastic. So your GitHub repository, your demonstration videos and stuff are fantastic. Really well done.
Yeah, it was really quick start, and I think this quick start in the guideline, it's okay, it's good for it. So about regarding to the gazebo simulation, I saw some results from our attenders from Japan. It was built whole hours in the gazebo simulation, and drone performed the flights inside the building, which was built by itself.
Fantastic! Really good to hear.
Yeah. So guys, what we didn't see any questions from your side, and now I think we can finish our webinar. So thank you all for taking part for this event, and I think we will see you in our next webinar. So dates and topic will be announced some later, but I hope, but I believe and I know that we will preparing something interesting for you and unusual. Yeah, Alek, what do you think?
Yeah, sure.
Yeah.
He sounds enthusiastic.
From my side, not from Alex's side. Okay, guys, thank you so much, and thank you all for your parts. And also, if you have opportunity to turn on your cameras, we can take a photo. I see Damian turned on and Stanislav. So, guys, what about other? Oh, Bruno, perfect. Bruno likes photo too. Oh, great, Dwayne, hi. Oleg, oh, guys, we are here. Amazing. Dwayne from Barbados. Yeah. Good morning.
Photo.
Okay. Are you ready to take a photo?
Okay.
3, 2, 1. Smile. Hey, great. So I see Raj from India, and oh, just a moment. And I see Pejun Chia. Hi. She is from Malaysia. Yeah. Yeah, great. Okay. So, and Mustafa, you will have only avatar for this photo. Okay, guys, last chance to take an amazing photo. And 3, 2, 1. Smile. Great. Thank you, everyone.
All right, guys, take care. Thank you very much.
Thank you so much. Bye bye.
Thank you. Bye bye.
Thank you.
Goodbye.
See ya.
Bye bye.